Have you ever wondered why we only see one side of the moon? Ah, the moon. Our closest celestial neighbor and a constant companion in the night sky. It's been the subject of wonder, curiosity, and countless myths and stories throughout human history. Yet, there's a peculiar quirk about the moon that you might not have given much thought to. We always see the same face of it, no matter where or when we look. This isn't by chance, no. It's due to a fascinating phenomenon known as tidal locking. Now I know what you're thinking. Tidal what? It's a bit of a mouthful, isn't it? But don't worry, we're going to break it down and make it as clear as a moonlit night. Isn't it fascinating? But what does tidal locking really mean? Let's dive into the science behind it. Scene script. Tidal locking, also known as gravitational locking or captured rotation, is the reason behind our moon's one-sided show. Now, what on earth is tidal locking, you ask? Well, it's not as complicated as it sounds. In the simplest terms, tidal locking is a natural phenomenon that occurs when an object's orbital period matches its rotational period. And this is exactly what's happening with our moon. Imagine you're spinning on the spot, and at the same time, you're also walking around a friend who's standing still. If you're spinning at the right speed, your friend will always see the same side of you. That's a rudimentary way to understand tidal locking. Now let's apply this to the Earth and the moon. The moon orbits around the Earth and it also spins on its own axis. But here's the kicker. These two motions, the orbit and the spin, take exactly the same amount of time. This is no cosmic coincidence, but the result of a powerful tango between the moon and the Earth's gravity. You see, the gravitational pull of the Earth has gradually slowed down the moon's rotation over billions of years. This slowing down is caused by tides on the moon, created by the Earth's gravity, hence the term tidal locking. These tides create friction, and this friction acts like a brake, slowing the moon's rotation until it matches its orbit. This gravitational embrace ensures that the moon takes about 27 days to spin once on its axis and the same amount of time to orbit the Earth. The result? We only ever see one side of the moon from our vantage point here on Earth. But remember, the moon isn't unique in this aspect. Tidal locking is a common occurrence in our universe. Many moons in our solar system are tidally locked to their planets, and even some exoplanets are believed to be tidally locked to their stars. So it's all about the moon's dance with gravity that makes us familiar with only one of its faces. So, why do we only see one side of the moon? As we've journeyed through this lunar puzzle, we've uncovered a number of fascinating insights. Let's take a moment to circle back and revisit the key points that have guided our exploration. Firstly, we delved into the concept of tidal locking, a gravitational interaction between two celestial bodies. In our case, this dance is performed by the Earth and the moon. Tidal locking, also known as gravitational locking or captured rotation, is a natural phenomenon that results in one face of a celestial object always facing its partner. For the Earth and the moon, this means we're always presented with the same lunar visage, often romantically referred to as the man in the moon. But it's not because the moon is shy or trying to hide its other side. Rather, it's a result of the gravitational pull between our planet and its natural satellite. The moon's rotation period matches its orbital period due to this gravitational interaction, causing it to show only one face to the Earth. This doesn't mean the dark side of the moon is always in shadow though. It receives just as much sunlight as the side we see. We just never get to view it from our earthly vantage point. Now isn't that something to ponder? The moon we see is not turning its back on us or trying to keep a secret. It's simply caught in a perpetual gravitational dance with the Earth. A tango that's been ongoing for billions of years. So the next time you find yourself gazing up at the moon, remember this intriguing tidbit. The moon isn't hiding its other half, it's just caught in a gravitational tango with our planet, revealing the same face to us day in and day out. And with that, we conclude our cosmic journey. Next time when you gaze at the moon, remember it's not hiding its other half, it's just caught in a gravitational tango with our planet. Thanks for watching and keep exploring the cosmos.